Okay, let's read the conclusion of a study here. We are 90% confident that the mean height of all adult US women, and the minute I say all adult US women, the mean really is the population mean. There's no reference to a sample, so we are 90% confident that mu, the mean height of all US women, is between 65 inches and 67 inches. Now, that range of values is called the confidence interval. So basically, this is what we're saying. So we're saying that if this is a number line and this is 65 inches and that's 67 inches, then we can be 90% confident that the mean is somewhere in this interval, but only with a 90% confidence can we say that. It's possible that the mean is not sitting within that given range. That is the confidence interval. So what exactly does this mean? It means that the mean most likely, with 90% confidence, we can say that it is between 65 inches and 67 inches. So what precisely does that mean? What does this 90% confidence really mean? So let me try to explain this. If this is the large population of US women, millions, adult US women, we can take, let's say, a sample of size, I'm just making this up, n equals 1500. So my first sample contains 1500. I take another random sample of 1500. I take another random sample of 1500. And you can imagine, I can take, I'm not going to say any particular number, but many, many, many such samples from the population. Many such samples. Okay. And each sample is of fixed size n equals something, and I said 1500. Now, in each of these samples, we have adult US women. What we're going to do is we're going to measure their heights and then find the average height. And this notation or this symbol is used for, X bar is used for sample mean. So that's the mean of the first sample. This is the mean of the second sample. This is the mean of the third sample. It's not necessarily true that they'll all be the same because the samples are different. The height measurements of the women in the samples may be different. So therefore, the average of the sample, which is X bar, could also be different. So from the many, many, many intervals, we calculate X bars. So we have many, many, many such X bars. Now, another thing we are going to fix is a confidence level of 90%. I'm sorry, that's not an N, that's a C. A confidence level of 90%. Now, once we fix the confidence level of 90%, for each of these samples, we are going to calculate the margin of error, and after which we're going to find the confidence interval. So this will be x2 bar plus or minus m2. This is x3 bar plus or minus m3. If you remember the formula, it is x bar plus or minus z star sigma over radical n. N is the fixed sample size. Sigma is the standard deviation of the population, and that is also fixed, obviously. So that's a number that we're going to use, and we probably know in the question, so we're going to use that. Z star comes from the confidence level C, and we're going to use table C to find that out. So that would be Z equals 1.645 from table C. Now, using this formula, we calculate these various confidence intervals. So now, what does the 90% confidence level really mean? Now, we have many, many, many intervals. Each of these is an interval. That's a confidence interval. That's a confidence interval. That's a confidence interval. And you keep going. You have many, many, many such intervals. The 90% confidence that we have really means that 90% of all possible confidence intervals, 90% of them contain the mean. 90% of them contain the mean mu. That's exactly what this confidence level really means. 90% of all possible confidence intervals that can be constructed from the many, many samples that we can extract from the large population, 90% of these intervals will contain the mean. It is possible that no matter how carefully we select our sample, randomly select our sample and do everything right, it is still possible, there's a small chance that the interval that we construct could be among those intervals that do not contain the mean. It's only 90% of all possible intervals contain the mean.